Voyager Pharmaceuticals will be creating advanced carbon fullerene by utilizing its partnership with Rain Cage Carbon. This is a review of how this highly specialized molecule can change the future of the radiology drug landscape. The most common fullerene is C60, carbon 60. Imagine a soccer ball made entirely of carbon atoms. This ball is not solid, it's more like a cage with holes. This structure is a molecule made up entirely of carbon. The basic structure of the carbon 60 molecule is that it is made up of 60 carbon atoms. Each carbon atom contributes the same number of electrons as it does in its elemental form. A single carbon atom has 6 electrons and 4 valence electrons per atom. These 4 valence electrons are what create the chemical bonds to create new drugs. Since C60 is a molecule made up of 60 carbon atoms, the total number of valence electrons in a carbon 60 molecule is 60 times 4 for a total number of 240 valence electrons per single molecule. Here's how these electrons influence the characteristics of carbon 60. Stability and structure. C60's 240 electrons are arranged in a way that contributes to its high stability. Each carbon atom contributes 4 electrons to the molecular bonding. These electrons are shared among the carbon atoms, forming strong covalent bonds. The arrangement of these electrons in a soccer ball-like structure, with a mix of hexagons, makes C60 extremely stable and indestructible inside the body at a cellular level, and this is what makes them a very safe contrast agent. Delocalized electrons. In C60, electrons are not fixed to a particular atom, but can move freely over the entire structure. This delocalization is due to the molecule's unique spherical shape, made of interconnected carbon atoms. This delocalization plays a significant role in its properties that make it suitable for use as a contrast agent in imaging techniques like MRI. Here's a simplified explanation using vanadium metallofullerene. Enhance relaxivity. In the context of MRI, relaxivity in MRI refers to the ability of a substance to alter the rate at which water protons realign with a magnetic field. Using a metallofullerene increases relaxivity rate, thereby enhancing the contrast and clarity of the MRI images. Delocalized electrons in C60 can interact with the magnetic field used in MRI, enhancing the magnetic properties of it. This interaction increases the relaxation times of nearby water protons, exponentially improving the quality of the scan. The ability of C60 to influence these relaxation times makes it an effective contrast agent. Paramagnetic properties. Delocalized electrons contribute to the paramagnetic properties of C60. Paramagnetic vanadium are attracted by magnetic fields and can enhance the local magnetic fields in an MRI scan. The mass of electrons in carbon 60 significantly enhances the paramagnetic properties of the vanadium, and this improves the quality of the MRI images by providing better contrast between different tissues. In summary, the delocalized electrons in C60 contribute to its potential as an effective MRI contrast agent by enhancing relaxivity, providing paramagnetic properties, and allowing for modifications to improve its targeting and biocompatibility. Reactivity. Despite its stability, C60 can participate in various chemical reactions due to the presence of double bonds between some of the carbon atoms. The electrons in these double bonds can be involved in reactions with other atoms or molecules. Conductivity. Under certain conditions, such as when doped with other elements, C60 can become conductive. This is again due to the electron delocalization throughout the molecule, allowing electrons to move more freely than in a typical insulator. These properties hold high value in the science of radiology and cancer treatment. Superconductivity. When certain metals are introduced to C60, the compound can exhibit superconductivity at relatively high temperatures. The electrons play a crucial role in this phenomenon, moving without resistance through the molecular structure. The creation of these metallofullerenes is essentially the creation of a superatom. All of these properties that we just discussed have amazing benefits for the drug development program. However, the functionalization of carbon 60 is what makes it so versatile as a drug. Functionalization. One of the key aspects of C60's reactivity is its ability to be functionalized, which means that other chemical groups can be added to its surface. This functionalization allows scientists to modify C60 molecules to improve their solubility in water, which is important for biological applications, and to attach specific molecules that target certain tissues or types of cells in the body. For a contrast agent, this means it can be designed to accumulate in specific organs or tumors, enhancing the contrast in these areas during imaging. Enhanced imaging. By attaching specific molecules, such as paramagnetic ions for MRI or heavy atoms for CT scans, to the C60 structure, its reactivity can be utilized to enhance the imaging capabilities. In MRI, for example, these modifications can affect the relaxation times of nearby hydrogen atoms, providing a stronger signal and clearer image. In CT scans, the attachment of heavy atoms increases X-ray absorption, improving contrast. Controlled release. The reactive nature of C60 can be harnessed to create contrast agents that release their active components in a controlled manner. This could be particularly useful where timed or targeted release of the contrast agent is desirable, such as in slow-growing tumors or in specific organs. Theranostics. This term combines therapy and diagnostics. The reactivity of C60 allows it to be used not only as a contrast agent for imaging, but also as a carrier for therapeutic drugs. This means that it can be used both to visualize and treat diseases like cancer, providing a two-in-one solution. What is a metallofullerene? Now imagine if we put a metal ball inside our soccer ball made of carbon. The metal ball doesn't stick to the inside walls. It just sits there in the center, trapped inside the cage, surrounded with a mass of high-powered electrons amplifying the atom's properties. This combination of a fullerene with a metal atom inside is called a metallofullerene. Why are metallofullerenes so special? The presence of the metal inside the carbon cage changes the properties of the molecule. These metallofullerenes have different physical and chemical properties because they have a metal atom inside, creating a superatom. The 360 electrons that surround the atom enhance the properties of the atom exponentially, creating extraordinary properties of the specialized molecule. Biocompatibility and safety. C60 is considered biocompatible and safe due to its stable carbon structure and antioxidant properties as a scavenger of reactive oxygen species, and low toxicity when properly prepared and used. Its unique spherical shape allows for modifications that enhance its solubility and biocompatibility, making it suitable for various biological applications and the radiology drug market. Voyager Pharmaceuticals is at the early stages of advanced carbon fullerene drug development and is on a promising road to creating breakthrough technological drugs for the future. Our partnership with Rain Cage Carbon, that utilizes their Eden carbon capture system to create advanced carbon, is going to bring advancements in the near future to the global radiology industry.